Okay, a couple of comments on the test. Looks like this. I don't know if you can see it on the screen, but I'm going to email copies of the practice test with the instructions. Basically, the instructions say you take the test in the testing center. Got to have your ID. You know that. But in case you didn't, now you do. Okay. And you're not allowed to take your calculator in. No aids, no references. You're not going to have internet. But they will give you a Casio FX 260 calculator, which is a pretty standard calculator. I do recommend that, and I don't see that people have too much trouble using that calculator, but I do recommend that before you take the test at some point, you go in there and ask them to let you play around with one to make sure you can do your basic calculations. Okay, just basic arithmetic. It doesn't do any graphing or anything like that. You have to construct your graphs, you know that. You know what's expected. You have a practice test that has every possible problem type on it, okay? The test itself consists of, and I didn't think to count them, I think 7, maybe 8 problems, but I'll count them right now. We got 1, 2, 3, 4, 5, 6, 7 problems. Out of the, I think they're about 17. Okay. It's basically one problem of each type. Okay. Like, in a kind of in order, first problem is we'll take one of those using transformations. Okay. One of the first 3. And then one of the 2 problems on inverse functions. One of the problem on piecewise functions. One of the 2 problems in rate of change. Actually, and then 1 or 2 problems in the rate of change applied. So actually 2 problems that involve rate of change, but they have different headings. And then one of the composite functions, and then one of the remaining 4 functions, we're applying a linear function. Okay. So that's what you're going to see. The other thing I'll tell you in advance is the week after we come back from spring break, there'll be a midterm exam, which is going to be this stuff plus material up through polynomials, which we're going to get to the week we come back from spring break. Not too bad if you get a few things down very well. Be a lot of the same material that's on the major quiz. Remember, the major quiz counts as a test, counts as half a test. But if you do well on it, it counts as a whole test. So do well on it. It's the one that's easiest to make a high score on. So take advantage of it for 2 reasons. One, if you really understand everything here and do really well on it, it means you're in pretty good shape. If you just keep moving along like you are, you're probably going to be successful in this course. Maybe you're going to be very successful, because a lot of you are on track to be very successful. Okay. So do the best you possibly can there. Okay, with that, we're going to turn to the quiz for today. And right here's the quiz, in case you're viewing this and you weren't here. So let's just quickly see what it takes to solve these problems. Okay, so first one is absolute value of 2x plus 3 equals 4. Well, this means either 2x plus 3 equals 4, because of course if 2x plus 3 equals 4, its absolute value equals 4, right? But also 2x plus 3 could equal -4, because obviously if 2x plus 3 is -4 and you're taking the absolute value of it, you're going to get 4. So this splits into 2 equations. That's the first thing you do. Now I see people trying to add 3 to both sides of the equation in this form. You can't add 3 to something inside absolute value signs. I mean, you can, but if you're trying to add to both sides, it's not gonna work. You can't add 3 to something that's squared. You can't add 3 to something that's got a square root. It doesn't work. Okay, and you might think about why. In any case, it's very easy. Once you understand that whatever's in here can either equal 4 or -4, so obviously that the absolute value be 4 either way, then you get 2 equations, and all you gotta do is solve them. So, well, I'm not gonna go through the steps of solving. You subtract 3 from both sides, you get 2x equals 1, you get x equals 1/2. Here you get a -7 over here, you get half of that, you're gonna get x equals -7 over 2. And you put 4 here. And then your solution set, you put brackets around it. And you generally put the least lesser one first, but I'm not gonna count it wrong if the order is different, okay? Now, with an ordered pair, the order makes a big difference, because one of them's the x, one of them's the y, right? But for a set, they could be listed in any sequence. It's easiest if they're listed in some logical sequence, because then you can more easily see what's in there. With just 2 solutions, it's not such a big deal, though. Okay. So now graph. Okay, it's f of x. Usually we use f of x for the toolkit function. The toolkit function is the absolute value function. So you realize that this is of the form a times some function of x minus 12, absolute value function of x minus 12 plus 14. Okay? So we write 2g of x minus 12 plus 14. And that's, of course, a g of x minus h plus k. Of x is the absolute value of x. In other words, we're identifying this as a shifted, stretched toolkit absolute value function that has that V shape. Okay, now a lot of people got this, a lot of people didn't. A lot of people tried to set this equal to 0, which gives you some information, but it isn't all that relevant to graphing it, okay? And those who did set it equal to 0 did a nice job of solving it. That was good to see, but you know, we're after the graph. So this is really what you need to see for the graph. So the vertical stretch is A, which is 2. Horizontal shift is H, which is 12. Vertical shift is K, which is 14. Well, your toolkit absolute value function, as I've told you to graph it. Graphed like so. Your toolkit points are going to be here, 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 and here. So there's a graph, and you can see why. Okay, so there it is. For the toolkit function, of course, this is y equals -2. This is y equals 2. This is y equals 0, and it's obvious this is y equals 1 and y equals -1. Here we have x equals -2, x equals 2. X equals 0, and of course, Y equals 0 is the x-axis, and X equals 0 is the y-axis. There's the toolkit function. Stretch, stretch, vertical stretch, 2, mean, we're going to go from Y equals 4, Y equals -4, with Y equals 0 in the middle. X is still going to go from -2 to 2. The vertex is still going to be here because we haven't shifted a thing. We have stretched. Now it's twice as steep as it was. Goes over 2 and up 4. Now, if we draw this same picture, here, and didn't mean to use red chalk over here usually. Confine that to the vertex, so it's at least make that halfway, right? Here it is again, exactly the same, vertically stretched by a factor of 2. But now this point is Y equals 14, and this point is Y equals 12, X equals 12. Because you've horizontally shifted 12 units, the vertex will move from X equals 0, 12 units. 0, 12 units gets you at 12. So the vertex goes at X equals 12. Then you vertically shift it 14 units so that the vertex has to shift up to Y equals 14. The scale is identical. Okay. When I say the scale, the size of the rectangle is identical. So instead of Y equals 0, you have Y equals 14. It's 4 units from here to here. It's 4 units from here to here. So this is Y equals 18. This is Y equals 10. And this is still X equals -2 and X equals 2. And now you've got a complete picture of the absolute value function that we have here. Now you should understand transformations well enough to understand everything I've just said. If you don't, go back and review it. We did a lot with it early in the semester. And the first 3 problems on the test, none of them involve the absolute value function. Okay. And I probably don't have a problem on here that involves the absolute value function, but you can guarantee that it's going to be a valid problem for the midterm. Okay. And it's treated just like a squaring function. Okay. Although if it was a squaring function, the vertex would be down here and the thing would have a parabolic shape. Okay. But you're still doing the same operations. Okay. So there we have it. So that's how you graph this thing. You don't make a table. If you do make a table and center the table at 1214, I'd probably give you some credit, but I really want to see the transformations for full credit. The reason we use transformations, and the reason we recommend transformations, is if I tell you to make a graph of this and you make your scale from -10 to 10 and make a big old table, you're not going to get the vertex. You're not going to get the central point of the function. Your graph is not going to be symmetric. It's not going to be very useful. Okay. So there we have it. Make sure you can do that. Make sure you understand transformations. It's one of the things that I'm going to guarantee that if you pass this course, you know about transformations. Even if you forget it the next month, it'll be there for you if you need it later, and you will often find that it's good to know. Okay. Now, if y is proportional to x, okay. Guess I might as well use a little space here. Y proportional to x, you immediately write y equals kx. That's what it means for y to be proportional to x. Now you have to find a value for k. Well, you have the information that when x equals 2, y equals 7. And write out my words. The words I used last time or the words I'm using now. Or your own words as long as they have the same content. This tells you use this known information. Write 7 equals kx. So k times 2. So k equals 7 halves. Thus, y equals 7 halves of x, as long as this proportionality is in effect. So if x equals 9, y equals 7 halves of 9, which is 63 over 2, which is 31 and a half. Okay. Now, there are other ways to see it. If y is proportional to x and y equals 7 when x equals 2, that means y is 3.5 times x. 3.5 times 2 is 7. So you do 3.5 times 9, you're going to get 31 and a half. But I want to see it written out formally because you can't always see it as clearly as you do with the direct proportionality. If you have an inverse proportionality with the square, y inversely proportional to x. Immediately you stop and you write y equals k over x squared. The inverse means in the denominator of y is proportional to x squared. Okay, so you write this. Inversely proportional means things in the denominator. The x squared is what it's inversely proportional to, and there it is. Then y equals 16. With x equals, what was it, 8? So 16 equals k over 8 squared. So 16 equals k over 64. So k equals 16 times 64, which is 1,024. The logic is always the same. You just have to recognize what the proportionality equation is. Okay? And got a question. Remember, you're always welcome to throw things if my back is turned. Okay, if you don't like those big numbers, then you can tell me to read more carefully. Why is 16 when x equals 4? I was looking for x equals at a bad angle and I caught the 8 with my eye. And it wasn't right. If it had been 8, then this is what it would have been. But since it's really 4, and then we're trying to find it if x equals 8, well, we're going to replace 8 with 4. And then, of course, we're going to replace this 8 with 4 and this with a more reasonable number. And okay, now x equals 4, so it's k over x squared. It would be 4 squared. 4 squared is 16. 16 times 16 is 256. Okay. So again, it just follows. You just, right there's the form. Now, I looked at the assignment. Most people did the assignment. Okay. And most people made a pretty good score, maybe a perfect score in the assignment. Okay. This happens again and again. People make perfect scores in this assignment and then can't do it when it comes up on a test. Now, again, this isn't going to be on the major quiz. It's active as soon as I take it over to the testing center, which will be in an hour or so. Okay. But it'll be in the midterm. I guarantee it'll be there. Okay. So people tend to find it's pretty easy, so it doesn't make an impression on them. And then they forget about it and screw it up on the midterm and therefore make the letter grade lower than they should. All right. So please don't let that happen. This is the easiest thing that's going to be on the test, on the midterm. And the midterm counts as a full test. Okay. It's a significant part of your final grade. Don't let it go by you. Okay. You see how easy it is? Does it look easy? If you've done the homework and see what I'm doing here, it should look easy. If you've written the homework out in this form or in a similar logical form. Now, if you just put a bunch of numbers down on the page and don't tell yourself what you're doing, you're not going to remember it. But you'll have made an impression, and maybe if you review it, then you will remember it long enough to do it well on the test. Okay? Maybe you'll even remember long enough to apply it, because this is very applicable in the real world and in for further mathematics courses. Okay. Something that's not taught very well in our curriculum. Okay. Anyhow, here's your logic. It follows just like over here. We got k equals 7/2. We rewrote the proportionality equation with 7/2. We rewrite it with 256 over x squared. That's hard to read. It's a little smudge, but it's probably easier to read. Y equals 256 over x squared. If x equals 8, then y equals 256 over 8 squared, which is 256 over 64, which is 4. That's it. Okay. Now, there's a connection. And I might say more about this connection, and I might put the connection on the exam. The connection is, if y equals 7/2 x, then you have a graph of this thing. The slope should be slope is 7/2, and it goes through 0, 0. Okay. Now, what's this? Y equals 256 over x squared. Well, that's a little more complicated. You know about the reciprocal squaring function, which has a graph that looks like this. Okay, that's reciprocal square. Vertical stretch is 256. So instead of the 0.11 or -11, you have the 0.1, 256, and the -1, 256. Those are written kind of small, you can't see them. You know, let's say I have to digest this right now. But if you understand the toolkit functions, because you need to understand them at this point, you understand that the toolkit reciprocal square function has this shape. And we haven't been over the algorithm for constructing it, but it's very similar to the algorithm for constructing the squaring function. And you use the same grid and just use a different rule. Start at the left-hand edge and your lowest line, move over one up to one, two, over one up two. Start at the right edge on the lowest line. And move left one up two, left one up two. Very easy algorithm. But of course, you can calculate the numbers and relate it to what you have. Okay. So my point is that this very important reciprocal square graph looks like this. Okay. And you can even locate a point. If x is 1, obviously y is 256, right? Or the point 1, 1 is on the reciprocal square graph toolkit. Vertical stretch 256. That stretches that point to 1, 256. Okay, just a little extra on this one. So there it is. Okay. Now let's see where we go next. I strongly, highly recommend what we did in MDE 61 today. It worked out really well. People who were there were really on top of it. Okay. So I'm going to give you this picture and then we'll start talking about polynomial and power functions. Now, the second section of the upcoming chapter is on quadratic. Quadratic functions are just vertically stretched, horizontally and vertically shifted toolkit squaring functions. The function that we're going to look at today is f of x equals x squared plus 4x plus 3. Now, I'm not going to spend, hopefully not more than 5 minutes going over this because you can always go back to the video, but a lot of you are in a position where you can pretty well understand this just with a 5-minute introduction, okay? So whether you can understand it or not, be sure you know to come back to it and then go back to the MDE 61 for today and look at what we did, okay? So here's our function. How do we find the graph of a function? Well, we first find the intercepts. Okay. We find the intercepts. What are the intercepts? I commented there. We have graphed linear functions. The easiest way to graph a linear function is to find the x and the y intercept. Now, that doesn't always work. If your x and y intercepts are real close to the origin, it's kind of tough to do it. Or if one is real close and the other isn't, it's not very useful. Then you got to use the slope and an intercept, okay? And you should know that. But you should know, and you should have internalized it by now, that the x-intercept occurs when y equals 0, because here's this x and y axis. Where is y equal to 0? So y is equal to 0 here, and y is equal to 0 here, and here, and here, and here. Everywhere on the x-axis, y is 0, and if the point isn't on the x-axis, y isn't 0. Make sure you know that for the upcoming major quiz, because there are linear functions on it, and you might well want to graph the thing, and chances are it's going to be easy to graph if you use the intercepts, okay? So we have to automatically know. Also, any graph that we do for the next few weeks is going to have intercepts that you're going to have to find. You have to know that the x-intercepts occur when y equals 0. And the y-intercepts occur when x equals 0, because every point on the y-axis has x coordinate 0. Like in this case, 0, 3, which is the intercept for this function. Okay, so what are the x-intercepts? That's when y equals 0. Well, the function is y equals x squared plus 4x plus 3, or y equals f of x equals this. I put the y on the right because we're going to let it equal 0, so that when I put it in this form, setting the function equal to 0 gives us something to which we apply the quadratic formula, which everybody should know. Okay? And if you don't, well, there's the formula. What's the formula mean? That's what you use when you have a quadratic expression equals 0. Now, what's a, b, and c? A is what's in front of x squared, which is automatically 1 if nothing is there. B is 4. That's what's in front of x. C is the thing doesn't have any x on it. Okay, You plug those numbers in here and you get x equals -3 or -1. You could also factor that into x minus 3 times x minus 1 equals, or x plus 3 plus times x plus 1 equals 0. X plus 3 is 0 if x is -3, etc. And you can still get the same numbers because this one actually factors. Usually they don't. Okay, so sig factors. So here are x-intercepts. -3, 0, because why? X is -3 if y is 0. You know, we've assumed y is 0, we get x equals -3. That gives us this point, which is right here. And if x is -1, well, x is -1 if y is 0, so we get -1, 0, that's here. Now we get the y-intercept. That occurs when x equals 0. Well, if x equals 0, then this is 0 and this is 0, leaving us just 3. So that's really easy. When x equals 0, a quadratic function, you can just read it off. You want to think, well, that's 0, that's 0. So that's all I have left, 3. I wrote it out here, but the y-intercept is then 0, 3. So we have this point, and this point. Now we can draw a parabola. You got 3 points, you can draw a parabola, as long as none of them are directly above the others. It's real easy. So we draw a parabola. There's a picture of our parabola. Okay. Now, I also asked for the axis of symmetry. Where's that? Well, if you got 2 zeros, it's halfway between the zeros, it wouldn't be symmetric. Okay, it's also at -b over 2a, which comes from the quadratic formula. We'll emphasize that more after spring break. But that's really easy. It's really easy to find the axis of symmetry. You just have to know what question to ask and how to structure the problem. You ask yourself, what's the x-intercept? What's that mean? Oh yeah, y is 0. Okay, we do this. What's the y-intercept? Well, x has to be 0. Plug in 0, there's your y-intercept. Okay? Where's the axis of symmetry? Halfway between your zeros or at -b over 2a, which you can just read in your quadratic form. Just ignore the plus or minus, and there's your axis of symmetry. It's at x equals -2 in this case. We label a thing, and like the vertical dotted lines and the horizontal dotted lines, I think it's the easiest way to graph something when you enter what the scale is. Okay. Then you want to find the vertex. What are the coordinates of the vertex? Well, the vertex occurs on the axis of symmetry, so x is -2. How do you get the vertex? You plug in x equals -2. Plug in x equals -2, and the vertex is at y equals f of -2, -2 squared plus 4 times -2 plus 3. Gives you -1. Again, just plug in to replace x with -2, you're going to get -1. So the vertex is at 2, -1. Okay, well, now we know that this was the toolkit squaring function shifted 2 units to the left and 1 unit down. Okay. And we could write this function as y equals x plus 2 squared minus 1. That's our transformation form. Now, why is there a 1 in front of it? Because there's a 1 in front of this x squared. We'll talk about why that is later, but if you square this, you're going to get x plus 2 times x plus 2 minus 1, which is x times x plus 2 times x plus 2 minus 1, which is x times x gives x squared, x times 2 gives us 2x. 2 times x is another 2x. 2 times 2 is 4 minus 1. That's x squared plus 4x plus 3. Same formula. Okay. You can go from this form to this form anytime you want to. And you're still going to get the same vertex and the same graph. That's important to know. Also, it's important to understand that x plus 2 squared is not x squared plus 2 squared, which would be x plus 4. It does have x plus 4 in it because 2 times 2, there it is 4. Okay, but it also has a 2x here and a 2x here because you multiply these things together by the distributive law, and that's what it means to square something. You should understand that, because that's something people screw up all the time. I screwed it up once. And as soon as I saw what I'd done, I swore I'd never screw it up again, and I didn't. Sometimes I wanted to, looking at it, okay, no, that's not right. Okay. So don't screw that up. Well, that's it. Except, we ask a question like, okay, what values of X give us Y2? What do? You draw the Y=2 line on the graph. And you got the 2 points and you estimate your coordinates. Okay. I estimated X equals 0.3 for this line and X equals -4 for this one. I can plug those back in to the function. X equals -4 doesn't work out too well. X equals -0.3 works out very well. Then how can I get the exact value? Well, I just let Y equal 2. Y equals this, so this has to equal 2. So I write the equation where this equals 2. To solve it using the quadratic formula. I can't use the quadratic formula in this form. The quadratic formula has to have an equal 0 here. To get an equal 0 here, I add -2 to both sides, then I get this equation. I plug the A, B, and C of this equation into the quadratic formula, and I get X equals approximately -0.3 and approximately -3.7. That agrees pretty well with what I got here. It nails -0.3. And it's -3.7 is close to -4. My graph wasn't as good as the graph everybody in class group. They got -3.7. So I got one of them, they got the other. Now, these are not exact because we have a square root of 12 involved. Square root of 12 is not exactly 3.4. Okay, it's 3.46, 1.732, 3.464. It's actually closer to 3.5. So there it is. That's a process that you should be able to do as automatically as you can do the proportionality, but we'll spend a day on it. Okay. And there's a little more that I did that I think I erased. Yep, it looks like it. But those are the main points. Okay. Now, we're covering today. We could go directly into quadratic functions because you know enough to do it. Everything I just showed you there, if we did it a little more slowly, you'd pick it up. Okay. And many of you probably picked it up anyway because you're well prepared to do it, but not everybody could be expected to be at that stage at this point in the course. So what we need to do first, power function. X to the P. Okay. So you're familiar with that. Matter of fact, of the 5 main toolkit functions that are given by simple formulas, 4 of them are power functions. The other ones, well, what if P equals 3? Y equals X to the P becomes Y equals X cubed. Toolkit cubing function. If P is -1, you get X to the -1, which is 1 over X. the toolkit reciprocal. This is a toolkit reciprocal square. And furthermore, if P equals 1/2, Y equals X to the 1/2, which is Y equals the square root of X. Its square root is a function that's inverse to the toolkit square. So you've already seen a bunch of PowerPoint. And you know how to graph all of them except, well, almost all. I haven't given you the algorithm for the reciprocal square. I haven't given you the algorithm for the cube. Okay? So I'm going to give you the algorithm for the cube right now. You ready for this? Lie to you. Now the dimensions of this rectangle are 16 by 4, but it only goes up to y equals 8 and down to y equals -8. Put my 16 in there unthinkingly. Okay. So, and the red dot goes here. Now, when the red dot is in the middle, you're going to divide it up. This is all of it. And here it x equals 1. And here the x equals 1/2. And here at -1/2. There's your subdivision by vertical lines. It's identical to what you use for the squaring function. Okay. Or the reciprocal. Or the reciprocal square for that matter. Basically, for any power function with a whole number power or with an integer power. Okay. Now, if you have the x to 1/2, you got to do the inverse of the squaring functions. You got to do the switch the x and y in the table and all that stuff, which you know how to do. Might be on the test. If not, it's a pretty likely problem for the midterm. So everybody should understand this at this point. Okay. Now things get a little more complicated. You're going to need a lot more horizontal lines. So you draw a horizontal line here. It's halfway between 8 and 0. That'd be your y equals 4 line. Halfway between there and 0 would be your y equals 2 line. Your y equals 1 line. But we need 3 more lines. I'm sorry, 4. Can you fit 4 more lines in here? Each one twice as close to the red dot as the last one? They get awful crowded, don't they? Okay. But We can do the y equals 1/2 line, that's okay. Here. We still need 3 more horizontal lines. And that last one is gonna be really, really close to the x-axis, isn't it? Okay. So we don't need to try to draw. We just understand that they're there, and the last one is really, really close to the y equals 0 line, right? Okay. So what do we do? We're going to start at the upper right-hand corner. We're going to move over 1 and down 3. So we're going to have this point and this point. Then we go over 1 and down 3. We've only got one line here. So 3 lines, which is going to put us down on that third line, which is really, really close. And then we go to the red dot, which means the graph is going to be almost flat from here to here. And then it's going to curve up like this. It's going to be kind of like a parabola, but much flatter toward the middle and much steeper. Okay. So it's over 1, down 3. And then over 1, down 3. And then red dot. I'm going to put it that way. I could actually say that you need 4 more horizontal lines. Okay, actually I said you need 3 more because I was going to go for 1. The second one is going to be about there, really close. Then it goes the opposite way down. Okay, just a reflection. It's like this, but upside down and flip over. Okay, that's your cube. And I'm going to expect to be able to sketch that when we get to the midterm, which will be like the last week of the month. Okay. Okay, just quickly. If we have the reciprocal square function, as x approaches infinity, that means as we go further and further this way, what does the y value approach? Can you show with your fingers? Well, you're approaching the x-axis, aren't you? Get closer and closer to the x-axis. So your y value approaches 0. That's the limit of this function as x approaches infinity. As x approaches negative infinity, you still approach 0, right? Now, for this function, as x approaches infinity, what do you think y does? It also approaches infinity. This thing keeps getting steeper and steeper. It gets incredibly steep by the time we get over to here. This thing's going to be a mile high. Okay. It approaches infinity. As x approaches negative infinity, that means we keep going this way. This thing's going to approach negative infinity. Does that make sense? Okay, we have questions like that. It's what happens as x approaches infinity? What happens as x approaches negative infinity? If you have a polynomial, just quickly, blank space. Y equals this. As x approaches infinity, none of this stuff matters. The only thing that matters is the one with the highest power term. So you ask yourself, what does this do as x approaches infinity? Okay. If x is big enough, x cubed is going to be so much bigger than all the rest of this stuff that the rest of this stuff doesn't matter. So take that and see what open math has to tell you. And we'll talk about it on Thursday. And I don't think, take a quick look, make sure I'm not lying to you. I don't think, though, that we have another assignment after that one. I do have quadratic functions due the day we come back from break. But if I have room, I'll move that over one day so you really have a break and you can spend any time you need to spend over break if you can't prepare for the final exam or for the major quiz in time. So you would have break to do that. It won't be due until you come back. Okay, but get it done this week if you can so you can have a break. Okay, any questions on any of that?